Hello, this is Roger Liu with the Virtual Technology and Design Laboratory at the University of Idaho, and I'm here today to talk to you about building virtual cities with Unity3d. To start, what is Unity3d? Unity3d is a game engine, and it provides a graphical user interface for defining objects and environments, and it also allows you to write scripts that can be attached to those objects that can define their behavior and their attributes. This provides an intuitive environment for object-based coding. So let's start by talking about the concept of virtualization. What is virtualization? Well, most people think virtual and digital are synonymous, but I'm here to argue that they are not. So let's consider this image for a second. We have a young child playing with a toy truck. So think about what the boy is thinking about. Place yourself in, his mind's eye. To him, that's not just a toy truck, that's a real truck, and he can drive it around and experience what it's like to drive the real thing, or at least what he might think it is. So another way of thinking about this concept is through analogy. A crash test dummy is analogous to a real human. No one doubts the validity or the usefulness of a crash test dummy, at least when it comes to testing the safety of automobiles. In digital virtual environments, such as those that you can build with Unity3d, in digital environments, such as those that we can build with Unity3d, we can have the same abstract representations of reality within that environment. So take, for instance, salmon migrating up the river. We can create virtual salmon that share characteristics with their real-life counterparts, and we can create an environment that shares characteristics with their real-life counterparts, and we can see how they interact with one another. That, in essence, is the goal of building a virtual city inside of Unity. It will allow us to see how assets, things of value, interact with agents, people that have the capability of making decisions. So this tutorial assumes that you have no prior experience with Unity or with programming. I'll be using C# and Visual Studio to do the programming. We'll begin by opening up Unity. Now that Unity is open, we will create a new project. I am using Unity 5.3.4 F1. Alright, Unity is now open, and let's take a second to walk through the layout. So in the middle, we have the scene view. We can move about by holding down our right mouse button and moving the mouse to change our gaze. And then we can also move backwards by pressing S, forwards by pressing W, left by pressing A, or right by pressing D. We can also move up and down by pressing E to move up, or Q to move down. When you start your Unity, you'll probably also see a game window. Over here in the hierarchy are game objects that are inside of our virtual environment. So here we have our camera, and then here we have a directional light. These are added by default to Unity. Or the hierarchy defines what's inside of the scene. It can also define initial starting parameters for objects, and we can save this to files called scenes. So we can go File, Save Scene As, and a Unity project is essentially a folder on your computer. So when I created my Virtual Cities project, it created a Virtual Cities folder, and then inside of that it created an Assets folder. I'm going to go ahead and create a Virtual Cities folder. And then inside of this folder, I'm going to create a folder named scenes. Now I'm going to save this scene as development scene. Okay, and then down here we have our project tab. This allows us to view resources that are in our project. Unity keeps track of these files for us. We can add files such as textures or other files by dragging and dropping them into the project folder. We also have the console that will display information related to our scripts and to the game engine while we're in play mode. And then lastly, we have the inspector tab over here. Each game object in the hierarchy could have several components associated with it. So our directional light has a transform component and a light component. I can create a cube by right-clicking in the hierarchy, going to 3D Object and then Cube. The cube is added to my hierarchy, and then in the inspector we can see that it has a transform component, a cube mesh filter, which defines its geometry, a box collider, which allows it to detect when it hits other objects, and a mesh renderer that defines its visibility within the scene. Let's go ahead and get started by creating a terrain. First, we'll right-click in the hierarchy menu, then we'll go to 3D Terrain, and this will create a terrain in our scene. We can view the size of the terrain by clicking on the gear icon, and by default the size is 500 wide by 500 tall. We can also sculpt the height of our terrain, but for this set of tutorials we'll at least start by leaving our terrain flat. I should note that unlike many Unity tutorials, this tutorial is going to focus on building interactions between game objects and not so much on the appearance of game objects. We can see that the terrain has been nested underneath my cube. I can change this arrangement by clicking and dragging the terrain outside of the cube with the left mouse button. Our cube is positioned at 0, 0, 0 in the world space, and the bottom left corner of the terrain is at 0, 0, 0. I like to orient myself so that I'm looking down the positive z axis, and for me this works because I think of z as being north and x as being east. So let's go ahead and delete our cube object. And if we think about cities have lots of humans in them. They're probably the defining characteristic of a city. We could have a city with buildings, and we probably wouldn't call it a city. So let's go ahead and create a representation of a human. Let's right-click in the hierarchy, then go to 3D and Capsule. We can zoom in by right-clicking. We can see that by default, we can see that Unity has placed our capsule floating in our environment. Let's go ahead and move that to the terrain. We can click on the move icon to move our object and try to place them that way. I can see that I actually placed them below the ground now. Or we can just specify its location directly. I can zoom in on the capsule again to lock the scene view to it. we can see by default that the capsule is anchored to its midpoint. By default, when the capsule has a scale of 1y, it is 2 meters tall. So let's go ahead and add a material to this capsule so we can see it better. Inside of our virtual cities folder, let's create a materials folder. And then inside of this materials folder, let's create a material. We can name this material human, and we can drag it onto the human capsule. We can also rename the capsule here to human. And then if we click on human in the hierarchy and then go to the inspector, we can change the color of the human by opening up the drop down under the shader and then selecting a color. So to make sure this stands out, I'm going to go with purple. So now the human is colored. The lighting is a little bit harsh, so let's go ahead and turn that down by going to Window and then Lighting. Alright, so we need to expand this a little. Well, we can dock it to our... There we go. And then we can bring down the ambient intensity. Okay. So now we have a three-dimensional object in our scene that represents a human, but a human is more than just a physical object in space. So let's create a script that will define its behavior. We'll go to Virtual Cities and create a folder and then name it Scripts. Then we will create a C# script and we will name it Human. In the background, Unity has created a C# file or a .cs file that has this content in it. We can drag the script onto our human, and then when we look at the human in the inspector, the component is visible. We can edit this script by double-clicking on it. I have Unity configured to use Microsoft's Visual Studio as my code editor. I highly recommend that you use Visual Studio because of the IntelliSense that is built into it. IntelliSense is Microsoft's technology for giving you code hints, and whether you're a novice or an advanced user, these can be extremely helpful. By default, Unity formats C# code slightly differently than Microsoft Visual Studio likes. So we can change that by going to Edit, Advance, Format Document. Alright, now that Microsoft Visual Studio is open, the first thing we probably want to do is go to Edit, Advance, Format Document, and that will change the way that the C# file is formatted to be more consistent with how Microsoft Visual Studio formats .cs files. So as I stated before, this set of tutorials assumes that you don't have any coding experience, so you'll hopefully just kind of emulate, and then as you go along, hopefully you'll start to build an understanding of how it actually works. But to give you the gist of what's going on here, the first two lines are defining libraries that I'm able to use within the scene. So mono behavior is actually a class that's defined inside of this Unity engine namespace. System.collections is another namespace, and I'm not actually using it, which is why it's kind of grayed out. So within the class, we're able to define attributes. Attributes are things that are characteristic or inherent to an object, and you can think of these as nouns. So for a human, we could think of this as their age or their gender or their shoe size or their wealth or their salary. Those are attributes. Those could be attributes of a human. And then we can also define methods, and methods are verbs. And all Unity mono behaviors, which end up being components on the objects, they have a whole set of methods by default. Two of the most important are start and update. So when we hit play, the code that's inside of start will run. So if we want it to do something, we can put that code in here and it'll get executed. A second method, which is very useful, is update. An update is called once per frame. So if we want our component to rotate constantly, we can define that in update. So let's begin now by thinking about attributes of humans. For the purposes of the tutorials, let's think of the humans as being genderless. This will make defining the interactions a lot easier. Once we incorporate gender, it ends up being more than twice as hard, even though we only have two genders. You'll just have to trust me on that. Let's begin by first defining an age variable. So we could write something like public float age. So float means that it's a number that has digits after the decimal place, basically, as opposed to an integer, which can only represent positive and negative whole numbers, and zero, of course. There's other types of variables that we'll talk about as we go along. So if we go back to Unity and then click on the human, we can wait for we need to wait for Visual Studio to detect our changes. And now we can see that there's an age parameter under our human component. So we could actually set a default value here, but what I want to do is set the age of the human when we start. And to do that, I can type age equals random.range. There's two ways to call the random.range method, and we can see from this little IntelliSense help box that random.range can return a float if it's given a float, two floats, or random.range can return an integer if it's given integers. So to define floats, we need to type an f at the end. So if I want the age to be randomized between 0 and 60, I need to type 0f, comma, 60. And then every statement in C# needs to end with a semicolon. So I'll type a semicolon, and Unity formats it for me the way that it thinks it should be. So now if I go back to the editor and click play, we can see that in the start function it came up with an age of 28.48101. So if I stop that and play it again, we should get a different value. And now we have 19.33783. So the way this is set up, it has an equal chance of picking from the number line between 0 and 60. So that should actually be F there. Alright, so we might also want to define whether our human is an adult or a child. So we can do that by creating an enum or an enumeration. So above the human class, I'm going to type enum human type, open curly bracket, adult, comma, child, and then after the curly bracket, I'm going to type semicolon. And actually, I need to make this public, so I'll type public enum human type. And then inside of our human class, I can type public human type and then lowercase human type. So this defines a human type attribute that goes by the name human type. And then in start, we can set human type based on the age that was generated. So I could type if age is less than 18F, human type equals human type dot child. Else so here I shouldn't actually have a colon. I do Python, so that's just a bad habit. When I'm, well, at least when I'm doing C#, it's a bad habit. And then here I want to type human type equals capital human type dot adult. So we can test this by going back to Unity and hitting play. I actually should wait for Unity to figure out our changes. Okay, so Unity created our human with an age of 58.47, and it's an adult. So let's go ahead and save our scene. And usually in cities, there's more than one human, so we want to be able to reuse this object. We can do that by using Unity's prefab functionality. Inside of our virtual cities folder, let's create a prefabs folder. And then inside of the prefabs folder, I'm going to drag in the human. Now I can actually drag humans out of the prefab folder, and we can see that they have the same appearance as our other humans, and they also already have the human script attached to them. So let's go ahead and play this and see what happens. Alright, we can see that human number 3 is 29.56308 years old. We can see human 2 is 27.93759 old. 1 is 52. And this one is 38.819. We can also make changes simultaneously to all of our humans at once if we select them all. So for instance, if I want to change is trigger across all of them, I can click that, and that change will apply across all of our humans. I'm actually going to go ahead and turn that off. We can also interact with the prefabs by changing just one of them. So inside of here, if I add a rigid body component, and then move that up, it actually broke my prefab, so I'm going to go ahead and take this human and then drag it back onto the human. And so now if I hit apply, the changes that I made to this human should get carried through to our other humans. So we can see that human 1 now has a rigid body.